you'll be losing points off your own presentation. So make sure you're giving them the respect that they deserve and paying attention, asking questions, and helping them move their lesson along, because you're going to have to return the favor at some point.
Okay. Tell us when we're on the clock.
You are on the clock.
Okay. Hi, class. My name is Mike. These are my lab associates, Nick and Kaan. And today you'll be learning about the theories for the end of the universe. So before we begin, does anyone have any guesses as to what some theories could be for the end of the universe? Yeah.
The death or the collapse of the sun.
Alright, that's a good guess. We'll see. Algie?
Another Big Bang-esque thing happening.
It's a solid.
Yes, red shirt.
A lot of black holes.
Nice.
A nuclear war that ends the world.
And the universe.
Alright, well,
Leads to
I guess we'll have to find out. Yeah. But first, we're just going to check out this neat clip that's going to give us some background information about the theories of the end of the universe.
Ooh, I think I could use one of those. Where's volume, first of all?
In any situation.
Oh.
You know how this is gonna end, right? Like you and your guinea pig and the bacteria living in your bathtub and the Real Housewives franchise, all those things are gonna end. And of course you know that. But also big, permanent seeming things are gonna end, like the Earth and the Sun and this galaxy and that galaxy over there and the universe. The end's not gonna happen anytime soon, but give it some time and even the universe will change into something different, something we wouldn't even recognize, and then gone. How exactly that's going to happen is, of course, up for some serious debate, because what we don't know about the universe could feel like a universe. But astrophysicists, cosmologists, and particle physicists are pretty smart people, and they think about this all the time. So at this point, what do they think is going to happen to Earth, and to the solar system, and the universe in the far distant future? It's good stuff to know, just in case you happen to run out of other stuff to worry about. The universe is about 13.7 billion years old, give or take about 130 million years, but it hasn't always been the way it is now. It's believed that it was born with the Big Bang as an unfathomably hot, dense point called a singularity. The Big Bang didn't occur as an explosion, like you would think, even though it's called the Big Bang. And the universe didn't expand into space because space didn't exist before the universe was formed. Instead, think of the Big Bang as the simultaneous appearance of space everywhere in the universe. If you could picture that. I, for one, cannot. But the people who study this stuff say that the universe hasn't expanded from any one spot since the Big Bang, but that space itself has been stretching and carrying matter with it. So, the universe started at a single hot, dense point smaller than an electron or something, and at the ripe old age of 1/100th of a billionth of a trillionth of a trillionth of a second, this point began to expand faster than the speed of light in a process called inflation. It's thought that in the same instant the universe doubled in size at least 90 times, growing from the size of a subatomic particle to the size of a golf ball. Ta-da! Whole universe! From there, it continued to grow a little more slowly, and as it expanded, it cooled, and matter began to form. For instance, just 1 second after the Big Bang, the fundamental building blocks of matter, called quarks, start to assemble into subatomic particles like protons and neutrons. And for the next 380,000 years or so, as the universe continued to cool and become less dense, these particles began to structure themselves in a way that we would recognize. They started colliding to form atoms, protons and neutrons inside a nucleus tied up together with a tiny little orbit of electrons. Here, some of the first lightest elements like helium, lithium, and of course hydrogen began to appear. At this point, the universe transformed from a dense fog of particles into something transparent, but it also went completely black since no stars had yet formed. So the period between 380,000 years to about 400 million years after the Big Bang is what we call the cosmic dark ages, since there weren't any big objects emitting visible light yet. But for the next 500 million years after that, lumps of gas began to collapse enough to form the first stars and galaxies. The expansion of the universe gradually slowed as gravity tried to pull matter back in on itself, but then, about 3.5 billion years after the Big Bang, something weird started to happen. A force stronger than gravity began to overpower this pull and accelerate the expansion of the universe. This force, called dark energy, is a leading candidate for the title of least understood thing in physics. All we really know is that it's a repulsive force that causes the universe to expand at an ever-increasing rate. So at this point, you probably get why the fate of the universe is so tough to predict. Our information is profoundly incomplete. We keep finding out about stuff like dark energy, and we're like, oh, okay, that's going to take a minute to process. Anyway, a little south of 9 billion years after the Big Bang, our solar system was born, and then our little adorable planet showed up, and here we are. But what's going to happen to us? Because everything ends. I mean, the second law of thermodynamics tells us that as time passes, entropy, that is, disorder in general, increases on all levels. Stars, including our sun, exhaust their supplies of fuel. Planets come untethered from their stars, and galaxies break apart. We're not 100% sure about anything regarding the true nature of the universe, so the end could happen in a different way. In fact, a lot of really smart people think it will happen differently. But one thing pretty much everybody agrees on, there's almost certainly going to be an end. But here on Earth, we've got some things besides cold black nothing to worry about. Even if the end of everything does happen, you won't be around for it. Neither will I, and neither will our great-great-great-great-great-great-great-great-great-grandkids. They'll be past caring one way or another. Because on Earth, things are always changing. It's what makes life possible. But it can also be kind of unconducive to immortality, if you know what I mean. In the next 100,000 years, Niagara Falls will erode away into Lake Erie, the moon will slow down the rotation of the Earth enough that we'll have to add a leap second to our clocks every day, and if global warming doesn't tamper with it, we're due for another ice age. Oh, and the movement of the stars will render most of the constellations we see from Earth unrecognizable, which will make astrologers, presumably, really confused. In the next 1 million years, our planet is due for a good old-fashioned catastrophic extinction event. These have happened periodically over the past 4 billion years of Earth's history. It could be the eruption of a supervolcano, which have been frequent enough to change the game in terms of the history of life on Earth. Think of an explosion so major that sulfuric acid mixed with volcanic ash blocks the sun all over the world for like 10 years and sends the planet into a volcanic winter. It's happened before, lots of times. We've even survived one before, although barely. Some scientists think that the eruption of the Toba supervolcano in Indonesia 70,000 years ago left only about 1,000 breeding pairs of Homo sapiens to repopulate the Earth. And did they ever? Now, sometime in the next 100 million years, we're likely to be hit by a meteorite similar to the one that possibly killed off the dinosaurs, because things in space are not so far apart that they don't run into each other occasionally, and big space rocks have collided with the Earth for as long as there has been an Earth. In fact, that's probably what caused most of the major extinction events on Earth so far. Of course, some people think that we could destroy one of those space rocks before it punches us in the face, but who knows where humans will be anywhere 100 million years from now. 250 million years from when you watch this, we will make a full circuit around the Milky Way, in which time all the continents on Earth may have fused into a single supercontinent. And now we gotta start thinking about the sun getting bigger, because that's what's gonna happen next. In 600 million years, the sun will begin to enter the red giant phase, basically a star's midlife crisis. A red giant has fused all its hydrogen into helium, causing it to heat up and expand more than 100 times its original size. It'll take a few billion years for the sun to actually swallow the Earth, but its growing luminosity will probably cause enough climatic changes on Earth, like all the oceans evaporating, for instance, that in 1.3 billion years, all plants and animals will have gone extinct. And the only living things will be bacteria and archaea hanging out in little pockets of liquid water at the Earth's poles. In 1.6 billion years, even those extremophiles will be having a tough time of it. In about 3.5 billion years, the surface of the Earth will resemble that of Venus, and the Earth's orbit will widen with the growing, yet less massive sun until about 7.9 billion years from now, when the sun will swallow up Mercury, Venus, and Earth. Some researchers have suggested that if humankind has figured out how to survive that long, maybe we could lasso a passing asteroid and get a tow into wider orbit, or we could move on to one of Saturn's moons, like Titan, because at that point it might be a perfect place for us. 7.9 billion years, though. We are so not going to be around, but I love the optimism. Anyway, 8 billion years from now, the sun will become a white dwarf, which by that point will be about half its present mass, and by 14.4 billion years from now, it will be cool enough to be invisible to human eyes. It's been a good sun, though. You better appreciate while it's still keeping you warm. After that, our solar system is pretty much dead. Now, it's kind of hard to say what will happen to the universe. Every astrophysicist's got ideas, of course, and each idea has a kind of painful nickname. The big rip, the big crunch, the big freeze. Which scenario will win out mostly depends on dark energy. which we don't know diddly about, if you remember. Let's start with the Big Rip. Here, the rate of expansion driven by dark energy keeps growing and growing without limit, becoming so extreme that it actually overwhelms all of the fundamental forces of physics, from the gravitation between objects to the strong and weak forces that hold subatomic particles together. In which case, not only will galaxy clusters break apart and star systems dissipate, but every form of matter, right down to molecules and atoms, will be shredded into oblivion. Some physicists say that this could happen as soon as 17 billion years from now. Or another possibility is that, like 100 billion years from now, the strength of dark energy will diminish as time goes on, and the expansion of the universe will stop accelerating. In this case, if dark energy weakens, gravity might ultimately win the tug-of-war and pull all the matter in the universe back on itself. That result is referred to as the Big Crunch. But these days, a lot of bets are being placed on the Big Freeze. In this scenario, dark energy keeps the universe flying apart until everything gets so far flying that there's simply no thermodynamic energy left. There'll be no motion, no heat, no life, stars will burn out, new stars will stop forming, and the cosmos will dissipate into cold, dark nothingness. This party isn't expected to start for about 100 trillion years, so that's good news. But these aren't the only ideas, they're just the most popular ones. Some cosmologists think that as entropy in the universe increases, it will configure itself into something so complicated it will become a self-aware entity. So yeah, I'm with the guy who thinks the universe could become a giant brain. That sounds cool. But that's what's great about this stuff. Cosmologists are constantly bickering over questions like, is the universe even real? Are we real? How many universes are there? Is the universe going to recur over and over again in an endless cycle of big bangs? Why can't you unscramble an egg? Because when you're trying to figure out the nature of the universe from a tiny rock in deep space, there are no questions. If you have any comments or questions or ideas, you can get in touch with us on Facebook or Twitter, or of course down in the comments below, and we will endeavor to be a part of this discussion, which is bound to be a somewhat complicated one. And if you want to keep getting smarter with us here at SciShow, you can go to youtube.com/SciShow and subscribe.
Hope you enjoyed that video. This is you.
Alright. So, one of the deciding factors between whether or not dark energy will win out over gravity is the critical density of the universe, which is a certain point it is a specific value that the density, or that the universe has to have for its density in order for gravity to eventually become stronger than whatever dark energy is now, which I think it's about 5 atoms per cubic meter in just free floating in space. So it also determines what shape the universe takes in models, and there are like 3 different shapes that the universe was projected to have. It could either be flat, could have been like a parabola that extended infinitely, or it could have been a sphere. And because the mass of the universe is less than the critical density, we've determined that it's probably flat. So if the actual density of the universe is less than the critical density, the Big Rip is more likely to happen. If it's about equal to the critical density, then the Big Freeze is likely to happen. And if it's larger than the critical density, then the Big Crunch is what's going to happen. So, okay. Hit that twice.
So, the first theory of how the universe will end is called the Big Rip. And as you heard from the video, it will happen when dark energy is expanding the universe so fast that it just progressively tears apart everything, and the force of gravity that's tearing apart, that's expanding them, is stronger than the bonds holding the molecules together. So pretty much everything will be torn apart. And then also, the observable universe will be continuously shrinking, because as the universe accelerates faster than the speed of light, light will eventually not be able to reach the universe, and eventually the universe will just shrink to a size that is smaller than Planck's length, and no force like gravity, strong, weak, or electromagnetic can act upon it.
So the Big Freeze is the most likely thing to occur based on what we've observed. there's actually kind of two different big freezes that are possible. One is that it expands far, but not faster than the speed of light, so the big rip never happens, so that eventually everything just becomes cold and dead, which is where entropy reaches its maximum level, so that nothing can really exist. So everything's basically the same, which is just the heat death of the universe. So it'll continue expanding forever, but it will never expand fast enough for the force of dark energy to outgrow the force of whatever's keeping stuff together as it is. So it'll never get faster than the speed of light, and it'll never get fast enough to tear everything apart. But because of the second law of thermodynamics, the universe will eventually reach entropic equilibrium, which would just mean that everything in the universe becomes the same, because everything just becomes disorderly. So it's basically just a flat line of heat, and nothing exists anymore. And again, this is just the second law of thermodynamics.
State it, yeah.
Yeah, right. So the entropy of any isolated system cannot decrease. Such systems spontaneously evolve towards thermodynamic equilibrium, the state of maximum entropy in the system, which is basically just where everything is as basic as it can be.
Okay.
Just one thing I've heard of that is, like, if you think about time as the rate of change, or like as a measure of change, right? Like, without change, there's really no sense of time, right? Like, and so that's why they call this the end of the universe. Like, you wouldn't necessarily think that just spreading everything out would end the universe. If everything's so spread out that literally nothing can change anymore, because everything is so spread out that it can't interact. There's no like, basically everything is uniform. Then time has essentially stopped, because there would be no change. So it's an interesting way of thinking.
Okay, let's start the big crunch. First, to get something out of the way, do we have Spanish test tomorrow? I think we do. Yeah? Okay, we do? Good. Just gotta get out of the way. All right, big crunch. One of the scenarios predicted for the end of the universe, it is a consequence of how the universe began, that being the Big Bang. So if everything exploded and there's more matter and stuff, and matter attracts each other, eventually as it creates more matter, that matter will be like, whoa, I'm pulling everything together again, and then boom, it reverses. Now I'm going to explain that using smart people words. The theory is that eventually the universe will stop expanding and begin to collapse onto itself, crushing or crunching everything in the universe. This would create the biggest, blackest hole, just the biggest black hole, which could ever exist. All the mass of the universe being a part of it. As I said, sucks it all in on itself, creates a black hole, but doesn't really have anything left to suck in because all the matter is in the black hole already. In order for scientists to predict the Big Crunch, they need to know certain properties of the universe, like density. The density is larger than a specific value, as you saw earlier, known as the critical density, then an eventual collapse is highly possible, but not really, as we'll say on later slides. More Big Crunch stuff. Connected to this idea, another component of the Big Crunch is the gravity between all galaxies. It is believed that eventually, like a ball falls back down to Earth, all smaller galaxies will fall to larger, and then larger galaxies, pulling them all together, and that's how the mass attracts each other. This theory is unlikely due to the presence of dark energy, which keeps galaxies apart. So, we don't know what it is, so we don't know what it'll do, but there's no evidence that it's going away, which means there's no reason that this will necessarily happen. Moreover, scientists working Sudbury Neutrino Observatory have concluded Yeah, there might be an at symbol missing there.
I don't think it's just like the words.
Okay. Have concluded it is nearly impossible because they have calculated the mass of the neutrino. Oh, we learned about this before, didn't we? Yeah. And the combined mass of all the neutrinos in all of the universe does not yield enough density to stop the universe's expansion. This means, according to current knowledge, the universe will go on expanding forever, and either the Big Rip or the Big Freeze are a lot more likely. Final Big Crunch stuff. I got some more for you. I know you're hungry for this knowledge.
More about that neutrino piece.
Oh, yes. Okay.
Glad you asked.
More about the neutrino.
What?
Yeah, I will.
What does the mass of the neutrino have to do with the expansion of the universe?
Because everything is made from like 12 types of neutrinos, and so if everything is made from those types, then if you take the masses of those types, then you have the building blocks for the universe. Like if a building is made from bricks, and you know how many bricks are in it, then if you find out the mass of the brick, you can find out the mass of the building. It's like that for the universe, I think. The source is myself right now. I'm good at
Helps
improvising.
determine what the critical density of the universe, or what the density of the actual universe is by knowing how many neutrinos, or how much neutrinos lie. So it's how we determine that the actual density of the universe is actually less than the critical density.
I didn't know how they figured out how many neutrinos are in the universe. That would probably be the bigger question, but I'm just a high school student, so no.
You're a teacher.
Yeah.
There must be some sort of uniformity across.
Yeah.
Because you measure how much.
This is all speculation.
It's all about sample
There's
size.
like no fact
It's
here.
maybe the flux of neutrinos through the Earth. Generally around this area of the universe.
It's pretty much like how.
It's a lot of estimation, but they used I think they used a section of space and determined how many neutrinos pass through there in a given instant. And using that, they determined how many would pass through basically every part of space. Because they decided that it was about average. So.
Assassinate. Giving you detention. Okay. Final Big Crunch stuff. In order for the universe to halt expansion and eventually contract into a big crunch, the mass of the universe must be above a certain... I said that already. The stars and galaxies in the universe detectable by our telescopes and instruments only account for a small fraction of this total mass. I think that's new. An assertion clearly supported by indirect evidence. The rotation of galaxies... Yeah. So, total mass, you can figure it out by rotation of galaxies. It shows which galaxy is more massive than the other, and you can even calculate the exact mass based on the rotation, how big the radius is, and other stuff. Depending on the rotation of galaxies around each other, and even just like planets and stuff, you can figure out mass of one as long as you know mass of the other. So if we start with the galaxies nearby our own, like if this is our galaxy, and there's one over here, the way it acts relative to ours, we can figure out how massive about it would be, then galaxies, how they act relative to it, how big it would be. And it's like dominoes, except nothing like dominoes at all. Therefore, neutrinos were thought to make up a large fraction of dark matter in the universe, but with an upper limit on their mass. The total mass of the universe cannot reach the critical level. We have figured this out. So our universe will surely expand into infinity with all its remaining consequences. Basically, because of dark matter, as it said earlier, dark energy, it can't stop expanding. And I don't know how they know it can't because they don't know how dark energy works, but as long as it keeps existing. The Big Crunch model is discarded. The universe is predicted to expand into a diffuse dark nothingness during the consecutive degenerate black... This, I don't think it makes sense. All right, the universe is going to go on, and it's going to go to the Big Freeze or the Big Rip, basically. Black holes and things like that are much more likely to rip it apart. Planets will detach from stars that evaporate and form galaxies. This is the stuff they said before. The proton will decay. All stars will run out of fuel. Yeah, that's the other stuff.
All right, so we're gonna play an interactive game called Guess the Theory. So, how much time do we have left? All right.
Have time.
So, we're gonna split you guys up into teams, and then there's gonna be a descriptive sentence that has to do with one of the theories, and then as a team you have to guess which one, and then if you get it right, you get a point, and then whoever has the most points at the end wins. Question?
Is it Jeopardy style, or is it you submit an answer and get a point if you're right?
Yeah. It's the latter. I don't really know what Jeopardy style is.
Should I click
Alright,
it?
wait, no, we need to make the teams first. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so let's do like 4 teams of 3.
Whatever.
4 teams.
3.
4 teams of 3, 1 team of 4.
That's not helpful.
That's not this side, and then no. You've been evicted.
Okay,
Go sit over there.
you 4, and then Sabrina, you go with them 2 and back.
Or that.
With,
I guess that works too. We should split these up. I don't trust them working with each other.
okay, wait, hold on. We have 2 teams of
Make
3.
fun of that
Don't we need?
Kaan.
Just do my bros. Do this 4, that 3.
I think-
Alright,
it's
alright,
fine.
this works.
Yeah.
Alright.
All right.
So when you have your answer, send a representative up to whisper it to one of us.
Here we go.
Don't.
Yeah.
Alright, here we go.
Yeah, ready?
Ready?
Boom. Reverse Big Bang Theory. Big Bang.
Go,
Oh wait, you also need a team name. So when you're gonna come up, tell us your team name.
What team Hingle with Kringleberry?
What?
Hingle with Kringleberry.
Hengel with Kringleberry?
Liam, why are you coming up with this?
Guy who's gonna get drafted next year.
Your team name is Big
Nick?
Crunch?
Kringle.
Is that your answer?
Yeah, that
Liam, I can't hear. I can't hear you. Okay, their answer is Big Crunch. This team right here. What's your team name? Team Constant? Okay. That's not the good type of
Alright, we
name.
need a team name from you two.
They are the Constant, apparently.
That's what they are.
No, they're Hingle McKingleberry. We're Kingle McKingleberry.
Alright, what are you? Kingle McKingleberry.
Don't worry, Mr. Corcoran. I'll make up for this lost time with random notes in a moment.
Don't get us mixed up.
I don't think we talked about the shape of the universe. I know.
Mingles and Kingleberry.
You did?
Alright, nice job, guys. You all
Good job, you all got the right answer.
And you can all have an extra point for all getting it right.
There's still
So
kids starving in
hard.
Africa, so don't be too proud of yourself.
You all got it right, so you all get an extra point.
That's a red line.
That's right.
It scares me.
Alright,
Are we good?
So,
Next
next
one?
one.
Okay. Boom, universe accelerates faster than the speed of light. What is it? Oh, Mr. Corcoran knows it. He's got a girl in space. Would you like to participate in the games, Mr. Corcoran?
Which one are you guys?
Hingle McKringleberry.
King of the Kingleberry. Are you sure?
Big Bertha.
Okay. Wow, nice job, guys.
Yeah.
Still waiting on one group or not?
Okay, everyone get it?
Alright, nice job.
Okay,
One.
next one. Critical density equals actual. Oh, that's
working out
difficult. Oh, who's gonna get it? Who's been paying attention? Because I haven't.
Wait, guess the
What's Big Crunch?
story.
We get bonus points for being the first up every time.
Yes. Okay. They get bonus points for being the first up. Oh,
Not right now. We
Am I
can't
not
make up
allowed
new
to make
rules
that
right now.
choice?
You get a bonus point of -1 for being on that team.
Alright. Still waiting on the middle group?
Keep it going.
May? Still waiting on your group.
I mean,
That's the big freeze.
Oh. Okay, so you didn't come up and tell me, so you don't get the point.
Okay.
Which one?
So can I click next now?
So as
I'm gonna click next.
That is not
We're good.
Oh, it's them?
Nobody else can.
Alright.
You can get a head start if you want where they're like finicking around over there. Death of the universe.
Oh, okay, next one.
I showed him.
Why did we get on?
I don't know what that is. Check. Can you give me? I don't know what the answer is. Can you give it to me?
Guys, I'm very impressed with how well you listened.
Is that what it is?
You guys took a point away from us. I don't know why.
I don't know.
Right now, it's all right. We're gonna do a standings.
Why do we lose
Yeah.
a point?
So Liam and Yard Dogs are in first place with 4, and
Five.
Kingle McKingleberry and Kringle McKingleberry. Both
Team of
losing with 4.
Okay. Here we go. Next question. Light won't reach observable universe.
Ooh, which one's this? I don't know.
No.
I really wish I was listening during the presentation.
Want to go from this one?
It's not.
Stop taking away points from us. We've got every
I don't know what
single
you're
one.
talking about.
Whisper from here.
All right, so every group got it right except for the Yard Dogs because it's the big rip, not the rip.
Do you have something to say?